In this session, we will be discussing about limits and derivative. First of all, we can see what do you mean by function. Function means whenever you put some value, you will get definite output. For example, you are using the power button of your mobile. When you press it once, the mobile will turn off. And if you hold the power button, you will get the power menu. If you press the volume up button, you will get a one more output, that is the volume of the device will increase. Similarly, functions are something which will give a definite output when you give some kind of input. For example, if I say that is f of x, polynomial of x is a function, means that is x square, this is a function. If I put input as x equal to 1, you will get f of 1, that is output, as 1 square as the output. Now instead of x, if you put f of 2, you will get 2 square, that is 4 will be your output. So that's the basic logic, which means if you give some value, you will get a definite output from function. Now we can discuss with a simple example, that is a function f of x equal to 2x plus 1. In this case, the function, if you put f of x value and x, if you put x equal to 0, you will get f of 0, which is equal to 2 into 0 plus 1, which means 1. And again, if you put f of 1, you will get 2 into 1 plus 1, which is equal to 3. That is, when you put x equal to 1, you will get output as 3. Now this function, you can draw this function in a number line. How? That is, the x value will be there, the input values, which means what are the value you are putting from here, that are your input value. Now for each input value, there will be certain output, that will the function of x, or you can simply call y, or simply you can say this is y equal to 2x plus 1, a straight line equation. So you can directly calculate f of x values y and x. You have already done this, drawing a graph by putting different value of x and y. Now when x equal to 0, f of x value is 1, that is, when x equal to 0, y value will be 1. So x equal to 0, y equal to 1. And similarly, when x equal to 1, y value will be 3. X equal to 1, y value will be 3. So with the 2 points, you can draw a straight line. Now the straight line is also a function. That means whatever the x value you are putting, you will get a corresponding y value for that particular value of x. That's the basic logic of function, which means for every x value you put it in the function, you will get a y value, that is the output. Output is given by this y axis. Now that's the basic concept of a function. Function is like this, it's just an equation of x or x. For example, this is also a function, that is f of x equal to x square minus 2 divided by x minus 2. This is also a function of x. Whatever the value of x you are putting, you will always have a definite value for y. Now we can discuss what you mean by limit. Limit means, suppose I am taking a function, that is f of x equal to 2x. Now if I say this function's value at x equal to 2, that is f of 2 at x equal to 2, the function has a certain value, that is at x equal to, the function's value is 2 into 2, that is 4. That means if you are inputting the value x, you will get value 4 as the output. Coordinate axis, that is the coordinate axis. This function will have some value. That means in this case, the function is f of x equal to 2x. F of x equal to 2x will be a straight line graph. If you want, you can draw like this also. F of x means the y axis will give the f of x value. So when you put x as 0, you will get y equal to, this equation is y equal to 2x, you will get y equal to 0. When you put x equal to 1, y value will be 2. So from 0 comma 0 is origin is 1 point, and 1 comma 2, when x equal to 1, y will be 2. So you can plot the graph of y equal to 2x. That's how the graphs looks like. Now y equal to 2x graph will be like this. It's a straight line graph. It's a straight line graph passing through the origin. Now if I say let x equal to 3, x is equal to 3. For x equal to 3, what is f of 3? That is 2 into 3, that is 6, which means there will be a corresponding y value, which is 6. That's the logic. Now we are calculating the function's value exactly at a point 3, and we can directly calculate it as 2 into 3, which is equal to 6. Now we have the exact value of function at x equal to 3. Now the thing is, I need to find what is the value of function when in x is approaching 3. That means when x value is closer to 3, what is the value of function? Now the thing is, we can approach 3 from the number line from two different directions. That is 0 will be there, 1 will be there, 2 will be there, 3 will be there, 4 will be there, etc. Now 3 can be approached from either from the side of 0, or you can approach from the other side. Now when you approach 3 from this side, there will be a closer value that is closer to 3. I am calling that value is 3 minus. Actually that value is 2.9999 bar, which means we don't know how many nines are there. Suppose I am telling this number, that is 2.9, is closer to 3, then there is another number that is 2.99, again it is more closer to 3. If I am claiming this is the closer number, if I put one more 9, I can have another number. So we don't know exactly what is the number. This will be never terminating, and it will be going till infinity. Similarly, you can approach this 3 from the left hand side, that is approach 3 from a greater value of 3, that is 3 plus slightly greater than 3, that is the number can be 3.00, infinite number of 0 followed by a 1. For example, if I say in number line, if I say this number as 3.01 is the smallest number or closer number to 3, then there will be one more number, that is 3.0001 will be there, which is further closer to 3. So we don't know what is actually this number. Now in this scenario, when I need to find the value of function at f of 3 plus, that is a slightly greater value from 3. What is our actual function? Our actual function is f of x equal to 2x. Now 3 plus means it will be f of 3 plus. That will be f of 3.000000 exactly, infinite number of 0 followed by 1. That is a number that is slightly greater than 3. Now we are approaching 3 from the which side of the number line? Right side of the number line. From right side we are approaching. Now in this scenario, if you want to find the exact value of this function, can you find it? Do you actually know this number? No, we don't have the exact figure of this number. So we can only find what is the value the function is approaching. That's the limit of the function. That is when we are reaching this function from 3 plus, that is the limit of the function from 3 plus, from the positive side of the number line, f of 3 plus will be 2x, that is f of x, which means we can only find the limit, which means what is the value the function is approaching from the positive side. That's how we are using the limit. With the limits we can only find, we can't find the exact value, but we can find what is the value the function is approaching. Limit x is tending to 3 plus f of x means limit x tends to 3 plus f of x is 2x, that will be 2 into 3, that is the function is approaching 3. But exact value will be this one. When you calculate with this one, it will be 6.0000 etc. 1. But this value we can't find it, because if you claim this particular number is the smallest number, if you put one more number, there will be always another smaller number exist, which is closer to 3 plus, which means if number, that is, if you say the function's value at the 3 plus slightly closer value, if you take, if this is the number f of 3.001 is a number, then there is another number again further closer, that is 3.00001 will be there. Now if you are telling this is the closer number to 3, then this is the, again there will be one more closer number, that is 0.000001. So in this scenario we can't have an exact value for this value, that is a slightly greater number for 3. So we can only find when the function's value is approaching 3 from the right hand side of the number line, we are using the term right hand limit. That is, we can only find what is the value the function is approaching, because this value we don't have an exact value, but with this one we can use the function and we can apply the limit, and we can say the function is approaching the value of 6. So that's the logic. We can only find left hand limit is when x is approaching 3 from its positive side, that is we are approaching 3 from the slightly greater value, that is the greater value will be always on the right side. So this will be limit x tends to 3 plus f of x equal to limit extends to 3 plus f of x is actually 2x, which is equal to 6. Similarly, in this number line, 3 can be approached from the lower value. That is, if you take a value 2.99999, it is closer to 3. But if I say this is the closer number, again one more number will be that is further closer. If I take one other, if this is the smaller number, there can be again one more number which is further closer to 3. So this number is uncertain. So we can't have the exact value. So we can say when the function approaches x from the left side of the number line from a smaller value, what is the value of function where the function is approaching, which is equal to limit the x tends to 3 minus 2x, which is equal to 6. Here also the function is approaching 6. That's a significance, which means the thing is, if a value a is here in the number line and a function something like this graph is there, we can directly find the value of f of a, that we will get f of a, that's the value of function at that point. But if you take a slightly increased value, that is a plus, then we can't have the exact value, that is at a closer point of a, which is a greater number. We can't have the value of this function exactly because this number is not exact. So we can only find when limit of the function when x is approaching from this greater side of the number line, where is the function's value is going or where it is approaching. That therefore we will use the limit, and this is called the right hand limit, because we are approaching from the positive side of the number line. Similarly, our function, this point is a, function can be approached from the right side of the number line, we can reach the a. So just before a, there is a number called a minus. A minus means actually if a is 10, a minus will be 9.9999, a closer value to a, but it is a lower value. That's why we are approaching from the left side. So where the function's value is going, it will be limit x tends to a minus f of x. That is called the right hand limit. Now we can discuss with an example. For example, I am taking a function f of x equal to f of x equal to f of x equal to 2x plus 1 if x is a positive number, and 0 if x equal to 0, and simply if x is a negative number. Now the thing is, if I am putting x equal to 0, I will directly get the value of x as 0. That is, when x equal to 0, f of x value, the function's value is 0, because you need to use these functions definition. When x is greater than 0, this is the function. When x equal to 0, this is the function. When x is less than 0, this is the function. Now in this case, now I need to find the value of f of 0 plus. 0 plus means actually we can assume in the number line we have 0. After 0, there is a number that is slightly greater than 0, that is 0 plus. Let it be 0.000 infinite 0 followed by the 1. Now, if I want to find the value of that function when the value of x is approaching 0 from the which side, from the positive side of the number line, that is right hand side, that is we will be finding RHL. So when we approach the function from the right hand side, what will be the value of function? For example, when you approach from a positive value, what is the value of function? F of 0 plus. When the number is a slightly positive number which is closer to 0, whenever x is greater than 0, we use this function definition. So what is the function, actually function's value, that is 2x plus 1. Now the 0 plus plus, this number is actually 0.0001. When you apply this value, the function's value will be 0.00 etc 1 plus 1, and it will be 0.0000 etc 2 plus 1. Is this value accurate? We don't know how many decimals are there. So in this case, we can say the function's value is almost 1. It is approaching 1 when you are going to 0 from the right hand side of the number line. So in this scenario, we can only do that, we can find the value where the function is approaching, because this number is uncertain. Forcefully we need to round off this one. So we can say this value is approximately 1. So there we are using the logic of limit, which means we can find the value of that function or find for which value the function is converging. For that, we can use the term left hand limit, that is right hand limit. That is when you approach this function from a slightly positive value, that is x is a slightly positive value, x is tending to 0 plus, then what is the value of function which is equal to limit x is tending to 0 plus? What is the function definition to x plus 1? So when x is positive, we use the thing. When x is greater than 0, we use the definition 2x plus 1, which will be equal to 2 into 0, 0 plus 1 is 1. So here limit will give an idea that where the function is leading us. Similarly, when you are approaching 0 from the negative side of the number line, this side of the number line, that means we are approaching from the slightly lesser value. So at that time we use the term left hand limit, that will be limit x is tending to 0 minus f of x. When x is negative, we use the definition f of x equal to x, that is limit x tends to 0 minus x, which is equal to 0, x is 0. Or if you have the number, that is this number will be f of 0 minus will be f of minus 0.00000 etc. 1, which means we can only approach 0 from this side through a negative number. So here we are using left hand limit. Now the what is the value of function? When x is negative, the function definition is x, that is f of x equal to x. Now we are putting the value, our value will be minus 0.000 etc. 1. We can't find this accurate value because that number is that much closer to 0. We don't know how many decimals are there. More decimals, more will be the closer. So we can only find this number is approaching minus 0, that is simply 0. So that's why we use the term limit, which means limit will give the idea that where the value of function is converging or it is leading to, not the exact value of the function. Now the thing is, when left hand limit equal to right hand limit, here left hand limit is right hand limit is 1 and left hand limit is 0. So the function is doesn't limit doesn't exist. So if these values are equal, when you calculate right hand limit and left hand limit, then we can say the function has limit or limit exists. Limit exists. Or we can explain with an example. Let f of x equal to x square, simply x square. Now we need to find the limit of the function at x equal to 0. For that, first of all, we will be using limit x is tending to 0 plus. When x is tending to 0 plus, nothing is mentioned, so the function will be always same. So it will be x square. So the right hand limit will be 0. Similarly, left hand limit will be limit x is tending to 0 minus x square, which is equal to again 0, because we don't have a separate function definition. So in this case, LHL and RHL are left hand limit and right hand limit are equal. Limit x is which is equal to when x is approaching 0, f of x value is equal to 0. If the function definition is same, no need to do separately LHL and RHL. But sometimes they will give the function's definition as f of x equal to x if x is a positive number and minus x if x is a negative number. Now 0, I need to find the limit at 0 at origin. Now we can reach 0 from this side and this side. When you are reaching from the left side, we are using the left hand limit, that is limit x tends to 0 minus f of x. Here limit x tends to 0 minus. Whenever the x values are negative, that is from this side, this function's value is minus x. That is, this will be, when you put the value, we can find where the function is approaching, that is 0. And similarly, right hand limit will be limit x is tending to 0 plus f of x. When x is positive, we need to take this condition, that is when x is positive, we need to take this as the function's value, that is limit x tends to 0 plus x. Now directly put the value, we will get the value, that is this function is approaching 0. That is when x is slightly greater value, that is f of 0.000 etc. 1 will be equal to x itself when x is positive. That means this value is approaching 0. So here limit is both LHL and RHL are equal. So here limit exists. Now the thing is, whenever you want to find limit of a function, if you want to find RHL and LHL are separately, then there will be two different conditions for that point. Slightly greater value, there will be a condition. Slightly lesser value, there will be a function condition. If nothing is mentioned, simply calculation of limit, you can directly calculate limit x is tending to 0 f of x. There is no such a difference when x is greater or positive or negative, whatever it is. So at equal to 0, you can directly find limit x tends to 0 x square, that is both LHL and RHL are same because the same function definition we are using. Now the thing is algebra of limits. That is, if you want to find limit x is tending to 0, x plus x square. That is, we can say one of the function is f of x, that is equal to x, and another function g of x, which is equal to x square. Here these two functions are added. When you add two functions f of x plus g of x together, limit x is tending to a value, you can simply split the limits. You can simply split the limits. And if it is subtraction, you can split it. If it is a constant into f of x, that is, that constant you can take it outside. For example, limit x tends to 4x, then you can say 4 into limit x tends to that value a x, which means from the function you can take the constant outside. And when you multiply, you can multiply the limits. When you divide, you can divide the limits provided that the denominator is not equal to 0.